video. So just so everybody knows at home, if you only have to be here if you're cohort A. If you're cohort B, you can just start reviewing for the test. So you really don't have to worry. Here, let me show you what I'm talking about. If you look at our announcement for today, cohort B, you guys can just start working on preparing for Friday. So there's a 2.1, 2.3 review assignment, but it really doesn't exist. It's not something you have to submit. This assignment does not count towards the final grade. Points to 0, submitting nothing. I just wanted to put kind of all of our homeworks all in one place for you to go back to. But the most important thing is that 2.1, 2.3 test, which lists out all of the things that we're going to do and have done that are going to be on there. So the best thing you can do is just kind of go back through our old stuff and just practice and just kind of work through the things that we've been doing. And the old questions are great. I would just close my book and try them fresh. If you need more, then you just tell me. Okay, you just let me know. Okay, so if you are cohort A, stick around. But if you're cohort B, and you are going to be here tomorrow, then you are good to go. Cool. I would love this camera to work. I don't know why it doesn't like me. Hi, Miss Michael. Yay! You're the best. It was so entertaining.
I'm still like fired up.
Crazy, right? I know.
Yeah, I know.
Thank you, Miss Michael. What's up? Oh, quad erat demonstratum. Wow. No.
Okay, good.
That's close though. She found QEE and QVD.
And then I found.
Oh man, she did it. Where was it? Parking lot? Which parking lot? Walmart? Yep. Nice. If anybody else finds it, I'll give you the credit for it. QED, nice. First one though, Evelyn. I'm gonna write it down so I don't forget. That's awesome. I don't know why this video is not happy. I don't want the FaceTime camera. I want the other one. All right, I'm gonna have to stop recording. I'm gonna come back to this. Okay, I'm back, but I really want the other camera so you guys can see better. Come on. Let's try this. Maybe it doesn't work, it just doesn't work, but I just want the nicer camera, but it's just not recognizing it, it's not picking it up. Audio is fine. Speakers. Camera. This would not be good. I don't understand. Let's try it like this. There we go. Yay. Okay, good. All right, now we can go to work. All right, I did it. I fixed it. I did it. Let's present. Maybe it's just one of my things isn't working. Okay. Wow. One of my outlets is not working. Okay. All right. Well. Okay. Let's get started. See you succeed forms. Anybody? I'll take them. If you still need to bring it in, please do that this week. That would make my life so much easier because I have to scan them, get them to see you, get confirmation that they're in, and if we do that like the day it's due, I just don't want terrible things to happen and you not to get the credit. And I need this form for that to work. And so what I'll do is when I scan these, I will send you the copy so that so that you have it. I figured out why this camera wasn't working. Only one of my 2 ports here, my USB-C ports, seems to be active, which is fine. I don't need it. But I did want to talk to you about what's on Canvas now that I put up last night. The announcement for today for cohort B is for them to actually start looking at preparing for Friday and getting ready for that 2.1, 2.2, 2.3 test. And so what I did is twofold. Number one, I put an assignment on there, 2.1 through 2.3 review. That is worth 0 points. That is nothing going to be submitted because you don't have to submit anything to me. You do as much or as little review as you think you need to, okay? And on that review, what I did is I linked all of the homeworks and classworks and stuff from this chapter so far. So it's all in one place. You can go back and look at it. And honestly, that's your best practice. The questions that I think are worth you doing at home are the kind of questions that I'm going to put on this test. But the other thing that I put on there, which might be even more helpful to you in terms of like figuring out what you need to be able to do, is I put the assignment for the 2.1 through 2.3 test, where you're going to actually end up, it's out of 100 points and all that stuff. So, and on that, I wish I could show it to you, but I either lose the camera and I lose everybody at home. But you can look it up on Canvas. On Canvas, there's that test, and it lists all of the topics, the order that we've done them, and underneath each, I kind of bulleted out like the main ideas or like the skills you need to be able to do or the kind of questions I'm going to ask all in one place so that you're studying over the next week, which should start today, not Thursday night. It probably should start today. Is organized and easy to follow because I know that it's sometimes very confusing to figure out, okay, what's going to be on this test and what's not. I try to take that problem away from you and put it all in one place so it's easy. I'm going to keep secrets from you on what I'm going to test you on. I don't think that's fair because there's a lot of stuff we're going to do. And so that's where we're at. You have some stuff on Canvas. The review is just there for your amusement, really, but really just for your organization. But the test is where it lists it all out. And you can get to it right from today's announcement. If you're cohort B, you just click on it. And for you guys tomorrow, I'll make it very easy and linkable and clickable and all that stuff. And I think the best thing you can do, number one, of course, is go through all those old homeworks and really just try the problems again from scratch. Like, close your book. Don't look at your old answers. See if you can do them. Now that we've done them, can you do it? And if you can't, ask for more. See, Rose, I need some more intermediate value theorem. I'm really struggling with that. Or I need more of the stuff from today or Wednesday that we're going to do, because we're going to need today and Wednesday to get all this stuff done, to feel ready. So, but my hope is that you walk out of here on Wednesday with the test in hand. And you can work on it Wednesday, Thursday, Friday, and just get it back to me Friday. Giving you that much time is what makes me feel better about you taking it honestly. And using your notes, using old homeworks and whatever, I'm okay with that. And I'll probably ask the same question that I did last time, like, which questions did you use notes on? So kind of keep track of that, so I know what you really know and what maybe we don't know as well. But nothing else. Calculators are okay, of course. Notes are fine. But I'd like to just keep it there and see what you've got. And just an FYI, and I'll put this on Canvas too, when we take our 2.4 through 2.7 test here in a few weeks, whenever that happens, it will happen over 2 days. 1 day in class and 1 day out. Because I want to see what you can do without notes in class. Like, how much do you really know? I have to see where we all fit in that, because doing it with notes should be easy if you take good notes and if you have done your homework and if you pay attention and you ask good questions and all that stuff. So, but you might need help this week, and I want to help you. Okay, so you just got to reach out if you need that. But let's do some stuff. Let's learn some new things. 2.3. I'm gonna start over here. I don't have my books. I gotta get my books. And I'll try my best to just stay on these two boards. This is my workout for the day. That's at least what I tell myself when I eat bowls full of chips at midnight. Oh, God, the stairs. Yeah, that's a good one. Okay. Yeah, some of us got the COVID-19, but the different kind of COVID-19, right? Okay, cool. Why is this thing so weird today? Let's get you closer. Okay. All right, so the beginning of 2.3 for us happened on Friday when we started talking about the rational roots theorem. Being able to look at an equation and get ourselves a beginning place to look for numbers that might work. But that's not actually how the beginning of chapter 2, section 3 actually starts. And so I kind of want to go back to that, but I like starting with the rational roots theorem. We're going to use it today. Right? All the factors of a sub 0 over all the factors of n gives us some nice answers. I want to start first. Let me turn off some lights. With example 1 from the textbook, and a skill that I don't think you saw last year. I got to pull it up so I make sure I have the right numbers. Now I'm going to leave space over here to do a simpler example, but the question that I want to try to do is 6x cubed minus 19x squared plus 16x minus 4. And I would like to divide it. Now, if we just divided it by a number, piece of cake, just divide all the numbers, right? If I just divided it by like a power of x, okay, I just take each one of these and divide by a power of x. What if it was both? What if we wanted to divide this cubic by this linear? Now, to remind you of a skill you learned forever ago, if I had something like 21, and I wanted that to be my divisor, the thing that I'm dividing by, the divisor. If But I took a number like, I don't know, 3,493. I'm just making it up. And you didn't have a calculator. So you have this dividend of 3,493. And you have this divisor of 21. Think back to forever ago. How would you do that? Long division. But when you say simplify, what do you mean, Blaine? Like try to see if they had common factors, right? But seeing if like 3 or 7 or something like goes into these numbers, not all that easy without like actually dividing it, right? And so what we could try to do right away is long division, like middle school long division. I know. Ugh, is the reaction to that, and I get it. But how do we do it? Like, so here's our new problem, right? Divisor on the outside, dividend on the inside. How do you do it? So you try like 21 divided by 3. Well, not big enough, right? Okay, so 21 divided by 34. And you see how many times it goes in. How many? Okay, and you put that result on top. Okay, so however many times this goes into something big enough. Starting at the front though, right? Starting at the front, we see what we got. And we see what happens. Okay, and now what do you do? But why 21? Why am I going to put 21 down here and subtract? 1 times 21 result goes down there and we subtract. Okay, so 34 minus 21 is 13, right? And this result should be smaller than this. If it isn't, then we didn't multiply by enough, right? We didn't put a big enough number up here. Okay, so now we have 13, it doesn't go in, so what do? We bring this one down. Okay, so bring down the 9, and now it should be big enough. And we think about, okay, 21 into 139. No, I don't care about up these, I just care about this. So how many times does that happen? 21 into 139. 6 times? And now what do? 6 times 21, and you put it under here. So 6 times 20 is 120. 6 times 1 is 6, so 126. And you subtract. Not intentional that also happens to be 13 like the last one. Just weird. I'm telling you, I just made these numbers up. And then bring it down, right? Same thing. And you just kind of like repeat the process over and over again until you run out of numbers. Okay, so bring down the 3. How many times does that go in? How many times is 21 into 133? Probably 6 again, right? Because I think we'll probably be good there. 126 and subtract 7, right? Okay, cool. So we get a remainder of 7. Now we could keep going, right? Like decimals, but we'll stop here. We'll stop here. And so what this kind of tells us is that first, like 3493 divided by 21 is at least 166, right? But there's a little bit more, right? We have this 7 out of that 21 left behind. And although we could keep going with decimals, we'll stop right here. But what is that, like, what does that remainder of 7 tell you about whether 21 goes evenly into 3493? Like, what remainder would we want to see here if it was perfect? 0. And so if we get a remainder of 0, then 21 would have been a factor, a perfect factor of 3493. Now, you're right. We could do some simplifying because this will be 1/3, right? There's lots of other things we can do when it's just numbers. Okay? But this isn't just numbers. Okay? This is numeric long division. This polynomial long division. And it's the long way, for sure. Now, some things, when we have to do this kind of division, we need polynomial long division because it just doesn't work any other way. Wednesday, I'll show you a shortcut, which you probably have seen, synthetic division. Did you do synthetic division last year or no? Oh, good, nice. So it's all new. Okay, I'll show you a nice shortcut if things work out really, really nicely. But sometimes we're stuck with polynomial long division. But I just want to show you how it works. Okay, so really what this is is this, right? Divisor on the outside, dividend on the inside. And what I want to be able to do is kind of answer the same question that I asked you at the end here. Like, was 21 a factor of 3,493? I really don't know unless I divide. And I kind of want to answer that question here. Is x minus 2 a factor of this cubic? And because this by itself, just the cubic, is clearly not nice and factorable, right? It's not like sum or difference of perfect cubes or difference of squares or quadratic trinomials, like factoring by grouping isn't going to work. We're kind of stuck actually dividing to see how it works. And we're going to use the same process. So I call it, what I usually do when we have this kind of repeatable process is I write down the steps and I call it my how-to. So that when we apply it to other problems, we can just follow the same steps. And for me, I was always the kind of person that really liked to have the steps kind of written out. But it's the same thing. We're going to do it the exact same way. Okay. But because it's number, like this right here is really like 20 plus 1 divided by 3,000 plus 400 plus 90 plus 3. That's really what's happening. But we make it simpler by like eliminating all of that space, and numbers are easy because they have location, right? Ones, tens, hundreds, thousands, I like position within that number was super easy. And with the shortcut on Wednesday, you'll see it's just position that will matter, but now we kind of have to write it out the long way. But I'm going to do the same thing. I'm going to look at the number on the outside. I'm going to see if it goes into the first number on the inside. But to make it easier, because we've got different degree terms, what I'm going to do is I'm going to divide the first term of the dividend by the first term of the divisor. Basically, take the 1 on the inside and divide it by the 1 on the outside. So I'm going to do, now you don't have to write this side work down. You can just do it in your head. I'm going to do 6x cubed divided by x. This one, first one, divided by this one, first one. And of course, I'm going to write it in standard form so that the biggest ones come first. If they mess with us and they like screw up that order, whenever I write this out, like in standard form for sure, to make sure I don't miss anything. So, like it's us doing 21 divided by 34, or 34 divided by 21, right? Big enough on the inside, and the big part on the outside. But we've got different powers, so we just be careful. So what is 6x cubed divided by x? Yeah, 6x squared. But what I'm going to do is I'm going to line it up, because it's squared, over the squared term. Okay, so here we go. 6x squared is going to go right there. That's like me putting the 1 right here. Right, 34 divided by 21 was at least one of them. But then what did we do? What did we do with this 1 and this 21? Multiplied them together. Okay. So, I don't know, like take that and multiply by the divisor, whatever's on the outside. So take that result, I'll call it, take that result and multiply it by the divisor. Take 6x squared and multiply it by x minus 2. Now, you've got a binomial here, so the 6x squared has to get multiplied through both. But again, I'm going to line it up. So I should even say that. So line it up. Okay, and then I'll do it again. I'm going to line it up. So 6x squared times x. Well, that should be 6x cubed because we're just kind of undoing what we did over here. So these should be the same. If you're doing it right, these should be the same. But I also have to distribute it to the negative 2, so minus 12x squared. And it's all lined up. Line it up. Okay, so we did the 1 times the 21. We lined it up underneath. And then what do? Subtract it. Now we have to subtract straight down. subtract straight down. So cubes with cubes, squares with squares, whatever you have, let's subtract straight down. Now, I put the subtraction sign out front, and I drop everything that I'm subtracting in parentheses right here. So I remember that I just have to switch the sign of all of that, okay? And I see what I get. And that's what we did, right? We did 34 minus 21, and we wrote down whatever it was. Okay, now these are the same. They always will be if we're doing it right. So the cube terms should disappear. Okay. So those are gone. Now, negative 19x squared minus negative, okay, so plus 12x squared was negative 7x squared. So you just subtract straight down, and you see what you get. Cool. So subtraction done. So that was us doing 34 minus 21 and getting 13. What did we do after that? We brought that next number down. Okay, let's bring the next term down. Bring down the next term. So that was us bringing down this 9 right here. So we had 139. And then we just kind of did it again, right? We just kind of repeated the process. Okay, part 5, repeat steps 1 through 4. Divide the first term here by the first term here. So in my head, or off on the side, whatever's more comfortable for you. Okay, so negative 7x squared divided by x. And again, you don't have to write it down on the side. You can just do it in your head. But I want to make sure that I'm doing it right. Because if I do it wrong, this whole thing's going to just fall apart. But I'm going to take this first term down here and divide it by, again, the same first term out here. So negative 7x squared divided by x. What do you get? Negative 7x. Okay, and that goes up here. And because it's negative, I'll just use subtraction. If it was positive, I would just use addition. Okay, so divide the first term of the dividend, because I know that new piece there, by the first term of the divisor, and line it up. And so I did. I lined up the x with the x's. And so all my x squareds are going to be lined up, all my x's are going to be lined up, all my constants will all be lined up. But the idea is to take that result, that negative 7x, and multiply it by the divisor. Right, by that x minus 2, so I'm going to take the negative 7x, and I'm going to multiply it. Just like we took the 6 and multiplied it by 21 and wrote it underneath. So negative 7x times x minus 2, well, it better be negative 7x squared. It should be exactly what we started with, because we're just kind of undoing that same process. Because I just want that next term to disappear. Like the cube's gone. Okay, cool. Now the squared's gone. But I got to do it with the negative 2 also. So plus 14x. But then subtract. All right, part 3, subtract straight down. And that term, that first term, now the cubic is gone. Now I'm on the squared. The squared should disappear too. And it does. Negative 7x squared plus 7x squared, 0x squared. You don't need to write the 0. Like I didn't put a 0 out here. It just is gone. But the x is 16x minus 14x. Okay, that's, stick with the colors, 2x. That's me subtracting straight down. Bring it down. Love it. Bring down to minus 4. And I'm not done yet, right? Because I brought, that's me bringing the 3 down. And now that I've brought my last number down, or my last term down, I'm in the last iteration of this process. Repeat steps 1 through 4 one last time. Okay? So let's do it. Take the first term, 2x, divide it by the first term, x. Okay, so 2x divided by x. Write it down if it helps. Don't if you don't need it. What do you get? And it's positive 2, so plus. Step 1, divide the first term by the first term and line it up. So all my numbers lined up good. Now take that result, take this 2, and multiply it by x minus 2. Which is 2x minus 4. And then subtract. Now, the first terms are always going to disappear if you're doing this right. So 2x minus 2x, good, 0. But what's negative 4? plus 4. And there's your remainder. Now, this remainder of 7 over here told me that 21 does not go evenly into that 3,493. What does the remainder now of a remainder 0 tell you about what happens with x minus 2 going into that cubic? Is it perfect? And that's what we want. I want that result to give me that perfect remainder of 0, because if it does, what that tells me is that x minus 2 is a factor of that cubic. And I went from not having any clue how to factor that cubic to now not only like knowing how to factor, but now it's perfect. And I know for sure that x minus 2 went in. So here's what I can do. I can take something unfactorable using kind of those like nice algebraic skills that we have, and now I can factor. What I can do is I can say, I know something that goes evenly into this. I know that x minus 2 is a factor. Guaranteed. Why? Because polynomial long division gave me a remainder of 0. But I want to think about what's left. Like, what's the leftover piece? Like, think about this one, right? 21, we did this whole thing. We said, okay, I've got this whole piece. I've got this 166 for sure, and then I have this remainder of a divisor. But, like, okay, remainder of 0. So I divided by x minus 2, so what's left? Your quotient. Okay, so I know what that leftover piece is going to be. It's whatever's on top when you do your polynomial long division. 6x squared minus 7x plus 2. And now it's factored. And now we've gone from a cubic that I couldn't factor to potentially a quadratic that I have a lot more skills I can deal with. Right? Anything above a power of 2, I don't have as many skills. Like, I hope and pray it's the difference of cubes or sum of cubes. Or, man, I really just hope it's factoring by grouping. Right? And, you know, hope springs eternal, but it's fall. Right? We're not always going to have things that work out the way we want, but if we have a way to come up with this, something that I know for sure is going to be a factor, then I give myself a shot. And so while this is all good, how do we get to this point where we even know to start with x minus 2? Like, how do we get to this point if they say, okay, here's some function factor it. Like, here's our hope of getting some solutions. And what do we want to do? We want to factor, right? Evelyn, what do you think? Yeah. Think back to Friday. And what we did on Friday is we said, I don't know. I don't have a clue. Let me give myself a place to start. Let me list the possible rational roots, the rational zeros, the x-intercepts, and let's test them, right? And so let's recap a list, right, of how to figure out all of the possible rational zeros, okay? And really all it was, okay, let's look at the last number, and let's look at all of the factors of 4, in this case. All the different ways we can multiply to 4. Well, 1 times 4 and 2 times 2, so 1, 2, and 4. And then we did the same thing in the denominator, but we chose the first number, right? A sub 0 went on top, a sub n went on the bottom. So all of the ways to multiply to get to 6. Well, 1 times 6, never forget about that, but also 2 times 3. So I've got 1, 2, 3, and 6. And what we need to do is write out our options so we know what to actually plug in to see what works. And so here's my strategy. Okay, it's plus or minus a whole bunch of things. And I'm just going to write plus or minus this, plus or minus that, plus or minus this, so I don't forget. And here's how I like to do it. I take all of my options up top and put them over the first one. Then all my options up top, put them over the second one. Then all my options up top, put them over the third one. I just kind of repeat that process so I don't miss anything. So I've got 1 over 1, 2 over 1, and 4 over 1. Okay, so plus or minus 1, plus or minus 2, plus or minus 4. You're always going to have those choices because you always have a potential factor of 1 on the bottom no matter what. But there's others. And I want to write them all down. I want to see if I can get a nice complete list of what to look at. So now I do it again, but all over 2. So 1 over 2, 2 over 2, and 4 over 2. So plus or minus 1 over 2. Okay, I don't have that one yet, so I better write it down. I just want to avoid duplicates. And 1/2 was unique, so I write that one down. So, okay, so 1 over 1, 2 over 1, 4 over 1. Okay, 1 over 2, 2 over 2. Well, what's 2 divided by 2? Got it. I don't need to write it again. I'm not going to put 2 over 2. It's just 1. So that one's done. And then 4 over 2. What's 4 divided by 2? Got it. There's going to be those kind of those repetitive numbers sometimes that we just don't want to write down more than once. Okay, good. All of my options over 2 are all done. Now I do 1 over 3, 2 over 3, and 4 over 3. Those are all new for sure. So plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. And it's kind of a long process to write all these down, but it's an exhaustive list, and now I know what my options are. And I just do it again one more time, all over 6. So 1 over 6, 2 over 6, and 4 over 6. Okay, so 1 over 6. Nope, don't have that yet. 1/6. 2 over 6. What does that simplify to? Got it. 4 over 6. Got it. There's my list of possible rational zeros. 1, 2, 3, 4, 5, 6, 7, 8 times 2 for plus or minus 16 options. That's a lot to check. And there's no way I'm doing that by hand. All of that is happening in the calculator. Okay, where I go into Y1. I type in the function. If you've got a calculator, let's do it. Because I can't plug in up there, so I'm going to have you do it. Okay, jump into your calculator and type in Y1. What I'll do is I'll present my screen. I'm still presenting. Sorry if that was kind of annoying for you guys to watch that way. Somebody's got to tell me that. Let me know. And what I'm going to do is I'm going to go to Y equals. I'm going to type in my function. So there it is if you're watching at home. I'm going to go to table set. Oh, I pressed graph. Now I got to watch it graph. Okay. Go to table set and make sure that your independent is set to ask. I'll turn my laptop towards you so at least you can look. All right, there's my table set up to independent is set to ask. Then I actually go to the table, so second table, and I'll just kind of delete everything that's in there. Delete, 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 because I did this on a different function. And then I just start testing. 1, enter. -1, enter. 2, enter. -2, and I just see what happens. So I type in 1, I get -1, no good. Okay, I type in -1, I get -45, no good. Okay, I type in 2, boom, there it is, a result of 0. So now I can list the actual rational roots based on my result from the calculator. X equals 2 guaranteed. Why? Because it gave me 0. And if I plug in a number and it gives me 0, it's an x-intercept, there's one of my roots. Now, here's a good thing to keep in mind. What is the degree of the function we're looking at? 3, right? Highest power, because written in standard form. So what's the maximum number of answers we could be looking for? That same degree. And so we found 1. And so if I exhaust this list and I find all 3, I'm done. I got them all. And I might find them by like here, or here, or here, right? I might not have to look through all of them, but I gotta try them until I get more. Okay, so -1 doesn't work, but 2 worked. Keep time. Tell me what else you get. 1/2. Okay, so x equals 1/2 worked, and 2/3. So how many total could there have been? How many did we find? We're done. We found all of our x-intercepts. Now, but what I want you to understand is how does that help us? Because what eventually we're going to try to do is write the complete factorization. I want to factor this as far as I can possibly go. And I'm going to use rational roots to do it. Well, think about this. We tried x minus 2. We did our whole thing. And we got 0, which we liked. But really, we're kind of at this point right here. X equals 2 is a 0. And if x equals 2 is a 0, what factor did that come from to make it a 0? X minus 2, right? Because plug in 2 right here. 2 minus 2 is 0. 0 times whatever is 0, and it works. So what about 1/2? Well, if x equals 1/2 was a solution, let's write down what's called the factor theorem. If x equals some number is an answer. And I'm just going to say some constant. X equals c for some constant. If x equals c is a 0 for some function, let's call it f of x. Then we should be able to figure out the factor that got us there. And that factor is x minus c. Then x minus c is a factor. And that is called the factor theorem. Basically, what you're looking for is f of c is 0. Right? That's all we're saying. And that's what we did in the calculators. We plugged in some numbers, and once we got one that works, we stopped. We wrote it down, said, yep, that one works. I like it. So x minus 1/2 is going to work. But look at your coefficients. Do you see any fractions here? 6, 19, 16, 4. No, there's no fractions there, which means that my factors don't need to have fractions either. So could you give me a better version of that factor that would give me the same 0? No decimals. I mean, like, give me only whole number, like just integer coefficients that would eventually, like, set it equal to 0, and you'd still get 1/2. 2x minus 1. Because set it equal to 0. Add 1. Divide by 2. Here's how you do it. If your root is a fraction, you can write it like this to start. And whatever your denominator is, multiply by that number. X minus 1/2, multiply it by 2. 2x minus 1. Okay? And so the other factor, that 2/3, sure, x minus 2/3, absolutely. Guaranteed, no problem. But if I don't have fractional coefficients in my function, I kind of want to try to avoid writing it like that if I can. Your denominator is 3. Multiply by 3. 3x minus 2. And now what I've got is a complete factorization. What I've got, x minus 2, 2x minus 1, and 3x minus 2. I've got the perfect factored version of this function. Now, if you wrote it with these instead, if you wrote it with the 1/2 and you wrote it with the 2/3, there's only one thing you need to do to make sure that your function is still equivalent to the one we started with. Just drop your leading coefficient out front. Because what did we multiply? by 2, and then we'll multiply by 3. What's 2 times 3? Same thing. 6 works. Okay. So I'm good either way. Honestly, if you want to just say, I'm just going to drop the leading coefficient out front, because we always do, right? And just go with the factors with fractions, awesome. If you want to say, you know what, I want to avoid fractions and really write what would happen, I mean, think about like factoring that. Two numbers that add to -7 and multiply to +12. Okay, -3 and -4, and you factor by grouping or do the box. Well, you'd get to here. You would. But now we don't have to, because the rational roots theorem gives us all of our possible answers. And once I test them in there and I get a 0, I know the factor that it came from, and I can just factor. But polynomial long division is going to prove that it works. Okay, but we can use this as well. We're going to need polynomial long division for when things aren't factorable in the second half of this chapter. So I just wanted to show it to you now, but realistically, there's a nice, easy way to prove these linear factors with a leading coefficient of 1. Linear factor, leading coefficient of 1. Linear factor, leading coefficient of 1. Linear factor, not a leading coefficient of 1. Our shortcut on Wednesday will not work for 2x minus 1, but it will work for x minus 1. It won't work for 3x minus 2. I'd need long division to do that. The shortcut will work for this one. Now, it's going to be kind of rough dealing with fractions throughout that whole process, because we're basically going to take this long division and we're going to get excited. We're going to collapse it. We're going to shrink it all down and make our lives easier. Okay. So, big takeaways, factor theorem. Okay. If you get a 0, we know what factor it came from. And I can use either long division or our shortcut on Wednesday to prove that. And I'm going to need us kind of comfortable with that process. But I just want to show you one last thing before we go. Obviously, we're going to need some Wednesday to practice lots of stuff. But I just want to do one more example, real quick. 8x cubed minus 1. Now, is that factorable on our own without this whole process? What is that structure that you recognize? Difference of perfect cubes. So I could just factor it. And so I wouldn't need this whole process. And so don't think that I'm teaching you something new and now you have to use it all the time. Okay, use the fastest, most efficient ways to do whatever I'm asking you to do. You know, finding the x-intercept is really what we're struggling with higher degree polynomials, because some things just aren't factorable, like that one. Now, it is factorable, but not in the ways we know, right? This way, it's definitely factorable. And so let's do it. Now, it can be helpful to write this as something cubed minus something cubed. 2x and 1. All right? a squared, ab, b squared. Same, opposite, always positive. So I know, I mean, I can factor this thing, no problem. I can do it. But what if you didn't? Like, what if you forgot? You get to this test and you just space and you blank. You've got options, okay? We're gonna get to here. I can do it, but we can do it in other ways in case you get stuck, okay? And one of those ways is to list out first the possible rational, RAT'(L) roots, zeros, whatever you want to call them, and see what you get. All the factors of 1, okay, 1, over all the factors of 8, 1, 2, 4, and 8. And what you'd see is you get 1 plus or minus 1/2, plus or minus 1/4, and plus or minus 1/8. I know I'm running out of time. But here's the problem. The only answer is 1/2. And with a power of 3, with a degree 3, but only one rational 0, the other 2 have to exist. But what are our options? What could they be? Because if I have one rational root and a total of 3, I'm going to have 3 zeros for sure. What are the 2 possibilities? What could those other 2 be? They could be irrational. Absolutely. They could have just square root of something else in it. Square root of 7 or square root of 13 or square root of 5 or something. But what's the other choice? Huh? Imaginary. Now, when they have both a real part and an imaginary part, they're called complex numbers. And we have this quadratic formula. Just solve it and see what you get. So we have options for finding the rest of those zeros, and we'll kind of pick it up right there next time. Okay, so check Canvas tomorrow for probably just a little bit of practice of what we've got. But really, I really want you to kind of start focusing on review for Friday, so you're good to go. Yeah. When is it? Thursday. I was going to say probably before school. Absolutely. I will get there as soon as I can. It's tough for me to get to 7, but I will be there as soon as I can. For sure. You're welcome. Perfect. Sounds good.